gas training, what we get asked. My name's Hart, and in today's video, I'm back at Viva Training, and I've got some experts here today, and the trainers from Worcester Bosch. So we've got Worcester Bosch here today at Viva, and we're going to ask them what questions they get asked by engineers when they go on training courses. So really important questions. So hopefully for new trainees, for people that's been doing the job a long time, and even customers as well, really. This video should be absolutely amazing for you. So without further ado, let's go over to Rob and Mike.
So how do I diagnose a blocked plate heat exchanger?
Well, there's a couple of ways you can do it, but I think probably the best one that you can do is to run the boiler in hot water, as you normally do, and if everything's working just as it should, you should have no more than 10 degrees, maybe 10, 15, between the flow off the main heat exchanger, so that's the water to your taps, compared to the temperature of the water going into the plate. So most people have got an analyzer, most of you have got two clamps, one on the flow into the plate, one on the hot out. They should be within about 10 degrees of each other. If it's creeping up and going further, you've probably got a blocked plate.
Could we also find that on the boiler display?
Well, yeah, we can, because on a lot of the modern boilers, like Compact 4000, I 8000, you can see the hot water temperature and the flow temperature, so you don't even need to get your clamps out.
Perfect.
So, okay, one of the questions I normally get is, why does the red gasket on the kebab heat exchanger or the WB6 fail?
I love this question. So, usually, Mike, it fails due to a lack of maintenance or a lack of annual servicing. You've got to think times are hard and customers might not be getting them appliances serviced as regularly as usually would do. So, yeah, also if the boiler is run dry to a degree as well, we can damage the gasket that way.
Because it's going to get too hot.
Because it's going to get too hot.
Okay,
Yeah,
cool.
Absolutely.
So what I'm hearing is most of the time, you're probably failing because of neglect.
Yeah, usually because of neglect. There is also a technical bulletin on the Worcester Bosch website to help you with diagnosing if the gasket's okay on a service.
So that's like doing a sweep test around the top.
A sweep test around the top.
As well as your normal visuals.
Absolutely.
Yeah, awesome, thanks for that.
So Mike, sometimes when installers go to service a boiler, a common question I get asked is, why is there ribs or ripples on the kebab style heat exchanger?
Well, okay, there's a couple of things to that. So normally, I mean, people I've spoken to in the past, they'll say that, okay, well, the heat exchanger's ribbed, it must have failed. That's not actually the case.
Yeah.
If you've got a boiler that runs really hot under low pressures, like RI boilers, you typically find them in old houses, high temperatures, low pressures, you might get ribbing, and that's normal. And the ribbing's caused because you've got a stainless steel jacket around an aluminium core. Aluminium expands faster than the steel, and these dents start to appear. So just because you see them doesn't necessarily mean it's a problem. If they had a fault and the system was running dry at a period of time, they might start to develop then, but then you top it up, you look after it, and it's absolutely fine.
Yeah.
So just because you see ripples doesn't mean there's an issue. But if you see ripples and then you've got all this staining down it, or you've got this tarry stuff coming out the top, that's where it's got so bad that water's starting to expand out of it. That is a failed heat exchanger.
So when it comes to servicing and an installation, it's advise the customer and show them how to do that, topping up potentially?
Yeah, so if I saw it, I would be thinking a little warning bell. Okay, right, I'm seeing these ripples. Can I explain it? So I'd be like, right, let's take a water quality. What does that look like? Do I need to drain the system, refill it? Do I need to put more inhibitor in there? Can I do a clean to stop this getting any worse? So they're like preventative things. But what I want to get people away from is, if you see the ripples, does not mean it's failed. They can just be normal and expected.
Great advice. Thanks, Mike.
When you start fault finding, I know for a fact that you love to ask the customer lots of questions to get the best picture of it. What sort of questions are you asking them?
Yeah, first off, Mike, I don't take any tools into a job with me. The first part of call for me is always to speak to the customer.
Okay.
And I'm asking them things to do with their system and the fault that trying to relate those questions to the fault that they're reporting to me. So that can be anything as to, if it's a hot water fault, is it just from one tap? Or is it all the outlets that are affected?
Sure.
Is it one radiator? Is it all the radiators? Because at the end of the day, the customer lives in that house 365 days a year, up to 365 days, and they know that system like the back of their hand. And the reason you're there is because something is not quite right in that respect. So yeah, ask as many questions related to the fault as possible.
And it's really interesting to say that because, I mean, plenty of times you ask a customer, they're like, oh, actually, yeah, that radiator doesn't get hot.
Yeah.
Well, that's information.
Yeah.
Even the little nuggets.
Absolutely. And also customers sometimes don't think that potentially a partner or a family member doing work on the property is classed as work. So when you ask them, have you had any work done? They'll say no. So it's always worth just reiterating the question again, just to try and get a good answer.
Yeah, that's awesome. Thanks for that.
Mike, one of the big questions on my courses is, I get asked quite frequently, is why do plate heat exchangers get blocked and fail?
Good question. Okay, there's two potential reasons. Okay, so plates can get blocked because there's two sides to a plate heat exchanger. So you've got the water side of it, where you've got just your domestic water going through, and if you live in a particularly hard water area, unless you put scale protection on there, it's sort of as expected. It will scale up at some point, and you know those who are in really hard water areas will almost sort of expect that sort of thing. But you can do things to protect it. Scale reducers, you can put stuff like softeners on there. So that's one thing you do. The other reason is normally because of sludge and muck in the system. If you've installed the boiler and you've done like a really good flush on it and you've got all of the muck out of it, well, there's nothing to block the plate. And when you look inside of a plate heat exchanger, the channels themselves, they're so small, which is why it's almost always the first thing to block because it has the narrowest passages. So best things you can do is when you install it, do a proper flush, get all that muck out, and when you service it, check it. Check the water quality. Because if they've drained the system down or changed the radiator and they've just got fresh water in their inhibitor, that sludge is going to build up again and they're going to get the same things. So yeah, two reasons, sludge or scale.
So there will be test kits to find that information then? So
yeah, and there's loads of different ones. So you can just go basic with like a turbidity tube, but with the new Part L stuff, we should be using actual chemical test kits as well. So from the big manufacturers, you can get test kits that are really quick and really simple, and they're going to help identify those potential problems.
And also test kits to check for hard water and soft water as well.
Yeah, absolutely. So you can get even like little dipsticks that will do for lime scale as well. You can get TDS meters, or if you send off for a full lab test, something like the AD Pro Check, absolutely fine. They will do all of that.
That's perfect. Thank you.
You're very welcome.
So quite often on my courses, one thing I get asked about when we're looking at electrical safe isolation is why would we use an unswitched socket for a plug and a socket? Why would we use an unswitched socket?
Okay, fair question. So a modern boiler, it's a class 1 electrical appliance, okay? So, we have to be careful about the type of supply we have. And your traditional, socket with a switch is something what we call a single pole switch. So when you turn it off, it just cuts the live, which means the neutral and the earth is still intact. Now, you might not be aware of it, or you might not have tested for it at this point, but if the house has got reverse polarity or that circuit has got reverse polarity, you've created a broken neutral. So even though the boiler's off, everything can still be fully live. Now that's a dangerous situation to be in.
Yeah.
So if you have an unswitched socket, the only way to turn that boiler off is to pull the whole plug out. So you break all 3 poles. Now, that's good. It's still not the greatest because it'd be really nice to have the earth still intact, which is why we always go down this switched fuse spur, because it's double pole and it keeps the earth intact. You've got the extra level of protection. Now, it's worth noting as well that recently, because of the types of boilers we have and the types of equipment we have in them, we're starting to look more at the RCDs. So what you might come across is these RCD fuse spurs.
Seen them.
Yeah. So what they've got, normal fuse spur, 3 amp fuse in there, but it's got 2 switches, one for test and one for activate. And the RCD is built into it. But when it trips, when it fails, it cuts the live and the neutral. So that's why we do that.
Just one more on that then, while we're on fuse spurs.
Sure.
One of the other questions I get asked is, Is a 3 amp fuse, is that enough to blow if you were to touch something live?
No. It's really shocking. So when people, shocking, no pun intended,
Yeah.
but when we do the training courses, and one of the small things I'll get people to do is measure their own resistance.
Yeah.
And it's simple. You do Ohm's law.
Yeah.
They could be drawing, normal people, everybody, base level, say 100,000 ohms, okay? You remember Ohm's law, voltage divided by resistance is your current. So you're looking at 0.0024 amps. So when you grab those cables, you're nowhere near the 3 amps.
Yeah.
The fuse isn't there for you. It's there to stop electrical fires, to protect the equipment.
Yeah.
It's the RCD that's there for you.
Yeah.
That's the one. Yeah.
Perfect.
I've been asked recently a lot about hydrogen, about whether our boilers are hydrogen ready, but I think there's a little bit more to that, isn't there?
Yeah, absolutely. So I've been asked this quite a lot as well. And basically, at the moment on the UK market, there are no hydrogen-ready boilers as such. But what we do have, and what we've had for quite a long time now, for at least a decade, is hydrogen blend-ready boilers.
Okay.
That's where you can introduce a mix of hydrogen and natural gas in there, up to about 20% usually.
So that means that if somebody has a boiler now, as they start to bring in and blend in a little bit of hydrogen, for them,
no changes. No, you won't even notice it's there. And just as an interesting fact, if we started using a 20% blend of hydrogen in the domestic UK market, we would probably save about 2.5 million cars off the road at the moment.
That's incredible. So
amazing.
Yeah, it's exciting times.
Exciting
times. But don't be worried, because all your recurring equipment and the stuff you buy today
is fine.
Will last.
Yeah, absolutely. Yeah.
Awesome. Okay. All modern equipment, modern boilers are packed full of sensors, and they're normally called NTCs.
Yes.
What on earth is that?
So yeah, another good question. So an NTC sensor, Mike. NTC stands for negative temperature coefficient.
Okay.
And basically what that means is that when the temperature in the boiler goes up, the resistance through the component actually comes down. So we see a lower resistance measured through the sensor.
Okay.
We do also have something called PTCs. Can you guess what that means?
Positive?
Very good, Mike, you're latching on. So positive temperature coefficient sensors we don't use in our Worcester boilers that I'm aware of.
They're not really commonplace on the market.
They're not commonplace on the market, but back in the olden days, standard efficiency boilers, there were a few manufacturers that used to use them. So you might come across them out in the field at some point.
Okay. And these NTC sensors, you measure that as the temperature goes up, the resistance goes down. They're pretty accurate, aren't they?
Oh.
So if you know one.
Yeah. Spot on, absolutely. So if you have a sensor in an 8,000, for instance, and one on a 4,000, they are going to be pretty much the same resistance as you're looking for.
Awesome.
So Mike, we are moving into a new era when it comes to central heating, and engineers are really going to have to get savvy around system design. What are some of the benefits that are around low temperature heating design now?
Okay, cool. So basically, I mean, the main one is efficiency. The lower you can operate a central heating system, the less resource or energy you're using to heat it up, or the boiler can behave more efficiently. So since 2005, we've had condensing boilers, but I would hazard a guess that a lot of them don't condense very well because of the temperatures we're still using. So when you look at a condensing boiler, you have something called the dew point, which you might have heard, it gets batted around a lot, but the dew point is at what temperature you need to drop the product's combustion for it to condense. And if we can make it condense, that sort of tells us that we've extracted as much usable energy out of those flue gases as we possibly can. So the dew point is around the 55 degree mark, 53, 54, 55, something like that. So if I use low flow temperatures, I can guarantee that the boiler is condensing nearly all the time. And if it's condensing all the time, we are making use of every ounce of efficiency or of energy in there. So when you look at a gas boiler, we say they're 92% efficient. You buy it off the box, 92%. If you can get that return temperature down as low as like 35 degrees, your efficiency goes up to like 96% when you look at the guidance from like Domestic Heating Design Guide. So that will always vary, but you can improve your efficiency by having lower flow temperatures. So one way to do that is to design the system correctly, okay? But you can also do it from a retrofit kind of view. So you can install controls that will use lower flow temperatures at better times. So, you know, most of the people have got their boilers set at 70 degrees, let's say, 65 degrees. But you don't need that hot flow temperatures in the spring or autumn.
No.
So you could turn it down, and then come the winter time, you could turn it up. Well, that is the definition of weather comp.
Yeah.
As the weather changes, the flow temperature changes.
So what you mean is you'd have an external weather comp sensor to help with that?
Or if you had a smart control, you could do it via the internet, so you don't even have to fit the weather sensor. So there's loads of ways of doing it, but the crux of it is, the lower I can operate my heating system, the more efficient it will be.
Yeah. So on my courses, I use the analogy of return temperature is energy saving for the customer, and flow temperature is basically comfort for the customer, and it's a matter of finding a balance between the two.
Yeah, exactly. So on a modern condensing system, those differences, we're looking for 20 degrees.
Yeah.
But to achieve that, you need to balance the system correctly. The system needs to be installed and spec'd for it. So yeah, I mean, how many people just throw a boiler on and don't balance the system? So it's really important to do that, and it's not exactly hard either.
No.
So there's no reason why not, especially when you are talking to customers and all they are thinking about at the minute is how can I save money?
Money. Yeah.
Yeah.
Brilliant, Mike. Thank you very much.
So I get asked a reason by what is the importance of servicing a boiler? You know, do I have to do it every year? How essential is it?
Yeah, absolutely. So in the MIs, it will tell you to have a boiler service annually, and that is important for quite a few different reasons. So number one, you've got your guarantee that you may have on the boiler, or a warranty if it's another boiler.
Yeah.
So it's to kind of maintain that and ensure that the manufacturer will come out if you ever need them. So the other thing is for safety as well. So there are a series of gaskets that are safety critical inside of a boiler, and they need checking on an annual basis, or replacing as a minimum of every 5 years, or sorry, a maximum every 5 years. So yeah, we do have gaskets that need to be checked and inspected and changed wherever possible. The other thing as well, so we've got efficiency. So your heating engineer, while you're having your service, may actually be checking flow and return temperatures and range rating, and making generally the boiler more efficient. And that can also be done by checking system water, so primary system water or radiator water, to ensure that the chemical levels are correct and that there's no excessive debris in the system as well, and they'll tell you if there is any excess there. So
simple analogy, you wouldn't drive around in a car that wasn't serviced and checked, yet some people will have a gas boiler in their house and not give it the same level of priority.
Absolutely, yeah, and that's where the problems will occur over time. If you never had your car serviced, you would certainly notice some weird things happening, and it's no different with your boiler as well. Absolutely.
Makes sense. Thanks.
So recently on a fault finding course that I did, I got asked about the dreaded EA fault that you can have on some Worcesters.
Love it.
Yeah, I love it. Yeah. So what goes into an EA fault? What can be the cause of an EA fault?
Okay. Well, an EA fault, quite simply, if you get a fault code, depending on the age of the boiler, it might be a small fault code, EA, or on the more modern ones, you might get a number after it, like 227 or something like such. But with the EA fault, it's really important to bring it down to its basics. The boiler tried to light and it was unsuccessful. So when you're trying to think, okay, well, why did this EA fault happen? Really, the question you've got to ask yourself is, why would a boiler not fire? So straight away, the things I would be, have you got gas? I mean, it's simple, but have you got gas? Are they on a meter? Do you know what I mean? So start basic. First thing I'm doing, manometer on the gas test point. Then you've got to consider, like, is there a problem with the burner? They can block up. You know, do I have to clean the heat exchanger? Has it been serviced recently? It's your basics. Are the electrodes in good condition? Are they sparking? Is your rectification probe intact? So EA faults, yes, it is a broad range of things, but only look at the things that would prevent a boiler from lighting.
And these are usually quite easy checks to do, and kind of very basic things that we will be doing at that stage.
Yeah.
So nice and easy for an engineer to do.
Exactly. In order to get a flame, you need fuel, you need air, and you need ignition. start there.
Yeah.
Easy.
Perfect.
Me personally, I think training is as important as ever, but why? Like what's so good about training?
Yeah. So things in our industry are always changing shape and evolving. And I've got to kind of take my Worcester hat off a little bit now and say that we should be, as a heating engineer, we should be kind of attending different training establishments and different training centres, but also going on manufacturers' courses. And I obviously want you to come to Worcester, but there's also a lot of other boiler manufacturers and a lot of other training centres that can talk you through other manufacturers' products and also heating system faults as well. So the importance of training as we go into this new era of heating and hot water systems it's really pivotal. It will teach you about installer training, so you as an engineer, but it will also make you better in educating the customer as well, which as we go into this new era is going to be a real big piece of work to do. So I cannot stress the importance of training at this current time.
All right.
So just for my own curiosities now, Mike, so what do you think are the benefits of training?
I think training's always been important. Okay, I blanket, I think you can always learn something, always. Even if you go on a training course, I guarantee you'll pick something up. But I really value training at the minute. The industry is in a new state of flux. We've got new technologies coming out. We've got new regulations. We've got new legislation that is altering the way that we go about our normal day to day. So those of you that have been doing it for 20, 30 years and think, well, I've been doing fine, get in front of a trainer and you might actually realize that things have changed since you did that. I mean, if you don't go to an academy, you see people once every 5 years, or you learn at the counter. Well, you need a bit more than that now. And with the rate that things are changing, what you don't want to be doing is left behind. And I know there will be people out there that say, I'll be retiring shortly. Stuff's happening now. This isn't a case of I'll be retiring in 5 years, I can ignore it. It's now. Get comfortable, and it's only going to make probably your life easier because you'll find something out you didn't know. You'll make everything better for the customer typically because you'll do things the right way, in the best way. And 3, we're in this climate change thing, and if you can learn to do things as efficiently as possibly can and get everything running efficiently, we're all going to benefit from that. So I think now more than ever, training is so important.
I agree.
Thank you very much for that, guys. Really interesting stuff. Please remember, always read the installation instructions and any technical bulletins at the time. And these videos, never take any videos on social media as factual. Things change. People have different opinions as well. So it's always important that you contact Worcester if you're working on a Worcester or any other boiler manufacturer, and make sure that you get the correct information at the time. But thank you very much for that. If you've got any comments, please put them below and we'll try and come back and we'll answer them questions as good as we can. And if you do want to go on a training course, please check out Viva Training, and I'll put a link below to that. And we've got lots of fault finding and installer courses. So yeah, come and see us. Thanks for watching.